Yes.
Hello
Yes.
everyone, this is Nita Jadhav from IT department. Here I am presenting Mr. Keyur Bukani, Junior Assistant at UGVCL, to present the webinar on the topic Data Encryption Techniques for Secure Data. So I am handing over to the Keyur Bukani. Sir, please start your presentation.
Okay. Hello. Good morning, everyone. Uh, today, uh, today we will see presentation about data encryption techniques for secure data. So first of all, let me introduce myself. As Nita ma'am said, I am currently working in UGVCL. Most of you must know, and I have done my masters in IT engineering and BTech in IT from Nirma University. So first of all, we will see why we need to secure our data. Uh, Today we are living in a digital world where most of our transactions are occurring on online web portal and everything. Nowadays we use lots of social media as well, like Facebook, WhatsApp, Instagram, etc. So if our data is not encrypted, means if it is not secure, then uh, it is vulnerable to hackers. Means our important information can be stolen and it can be misused. Suppose you are purchasing anything online from, say, Amazon, and you enter your credit card essentials, your UPI pin, etc., your UPI ID and password, and if any hacker steals this valuable information, then uh, he may misuse this information and may empty your pocket also. So it is very important to secure our data in every online transaction, as well as while sharing your personal details or photographs, etc., on social media. You have to make sure that your information is secured. Suppose you are sharing your personal photographs on WhatsApp, then WhatsApp is providing end-to-end encryption, so we can uh, make sure that it is safe. But on other website, like in suppose you are using some other social media, then you have to make sure your data is protected. So it to secure your data. So uh, we will see how we can secure our data through various encryption techniques. I hope you all are about why it is used. So let's start with this presentation. Right. So encryption is nothing but the process converting our information into such a pattern that no one can understand what is the actual meaning of the information. Uh, Suppose I will say that hello, how are you? Then everyone who can understand English meaning of my uh, if I say something which is not easily understood by, uh, for example, all of you must have seen the movie Bahubali, in which the Katkei speaks in such a language that no one can understand. An example of ciphertext means no one can understand what information is being said. So, in our encryption field, it is known as ciphertext, or despite being available with the information. So, example, I am sending my information and making it encrypted with my encryption algorithm. And between hackers steals this text, means cipher text. But even if not deduce my information, what am I uh, trying to convey is that from our sender to receiver end, between transmission line in network, that is a vulnerability of data being stolen. But if your data is stolen, despite hacker cannot understand what is the actual meaning of that data. So that is why encryption comes in picture, and data should be encrypted. And hacker cannot understand data, but what about the receiver? Receiver also cannot understand the ciphertext, so receiver need to have some key, means this system is like lock and a key. If a receiver has a secret key, then he can open this lock, and using this secret key, or let's say password, he he can decrypt the ciphertext and convert into the original text which was shared by the sender. So uh, protection of data is ensured in this data encryption method. And uh, you may see in this diagram, say our original message is hello world, it is known as plain text, and using this encryption algorithm, the, this text is converted in some garbage text. So in the middle of the diagram, the garbage text is shown, which is has percentage GLU, and this garbage text is transmitted from sender to receiver. So in between, if a hacker tries to steal this information, he obtain the information of the message what sender has sent. Uh, at the receiver end, decrypt by information world. So in this diagram, so the text say hello is converted to some garbage text, or say cipher text, so that uh, no one can understand the actual meaning of the text. So history of the cryptography goes back to the times of Julius Caesar. You must have known the name of famous protagonist Julius Caesar. He has uh, he has used cryptography first of all in the history of mankind. So what he do? He did a normal thing. Let you can see in this picture that he shift the entire alphabet 3 steps further. Means A is coded as X, B was coded as Y, C was coded as Z, D and D was coded as A, E was coded as B, and carry on, like 26 alphabets were coded 3 places before. So suppose I want to send the message of Parul, P-A-R-U-L, then I will write, what I will write? I will write M, X, O, R, and last one is L will be coded as I. So it was used first of all by Julius Caesar. It he was a actor in the famous novel. This dialogue of Julius Caesar, and a famous text scripted by Julius Caesar is let we will see this example. He encrypted this line. Means this is cipher text using places shift upward of alphabetical game. So can anyone know what is the actual message? Means can anyone? I have given you the pattern to encrypt. He used three places up in alphabetical code. So can anyone get what is this line? So student can answer this or no? Chitesh sir. Hello. If students can allow, then it so okay. Let see this answer. What is the code for this encrypted line? I for decryption we have to use +3 text. Means I will be decrypted +3 means J K and L. So L will be decrypted M N and O. So third text will be included. So and so on. It will be decrypted like look behind you. Julius said look behind you, but it was encrypted in such a way that no one could understand. So ciphertext was why VLR, that was ciphertext, but actual plain text means the message he wanted to convey was this look behind you. So let's see algorithm of this encryption. And in algorithm of encryption, we need a key or a pair of keys to encrypt the plain text. And using this encryption algorithm, plain text is converted to ciphertext, and ciphertext is then transmitted to network line, and hence we can uh, relax that our data is secure. And if a hacker steals this ciphertext, he will not be able to understand what is the actual message, means what we want to convey. So all right, and at the receiver side, we have to decrypt the ciphertext. So receiver needs to have decryption algorithm and a key to decrypt the ciphertext. So we have to make sure that both sender and receiver have the same keys, and they already should have encryption and decryption algorithm. So receiver will receive ciphertext, and using decryption algorithm, he will convert it into plain text. Okay. So why we need to encryption? So there are four basic objectives of encryption. First of all, to ensure confidentiality of the message. That means that message should only be readable to the person for whom actually it is written. So no one else other than the actual receiver should be able to receive this message, and should be able to understand the message. So even if in between transition transducer eavesdrop the message, but then also he or she cannot be able to understand the meaning of the plain text, because it will be garbage text. So eavesdropping is eliminated, and the confidentiality is assured through encryption. Another objective is to make sure integrity of the message is achieved. What do you mean by integrity? Integrity means that the message that is sent, the, that message only is received by the receiver. Means receiver is assured that the message received by me is the actual message what was sent by the sender. So integrity is also guaranteed, and receiver can make sure that message is not modified in between the transition. So integrity is ensured through encryption, and the next objective of encryption is authentication. So in authentication, it is similar like integrity. Receiver can be at 100% sure that the message is authenticated and it is sent by the sender which was intended to send only, means no one other than the authenticated sender has sent him the message. So authentication is also ensured in this encryption. And the last objective of encryption is non-repudiation, means send if sender has actually sent the message, then it is also possible that hackers may send false message during the transmission, and more than one message are received by the receiver. So through encryption it is ensured that message is not repeated at the receiver side. So now let's see types of encryption algorithms. There are basic two types of encryption algorithm, which are symmetric algorithm and asymmetric algorithm. In symmetric algorithm, the key used for encryption and decryption are the same keys. Means the key which is used to encrypt the message, it the same key is used for decrypt the ciphertext to plain text. So only single key is used in symmetric encryption, while in asymmetric encryption, two two keys concept is introduced, in which one key is public key, which is known to everyone, but we are seeing symmetric encryption, and so secret key is common for both sender and receiver. So plain text from sender side is encrypted using secret key, and it is converted in ciphertext. Then ciphertext is transmitted, and at the receiver side, receiver uses decryption algorithm and converts this ciphertext in plain text using the same secret key. So if secret key is known to hacker, then he may easily understand what is the actual message. So we have to make sure that secret key is stored secretly, and secret key is sharing is the major concern in symmetric encryption. So let's see example of symmetric encryption. Very well-known algorithm used in symmetric encryption is data encryption standard. You must have known this algorithm in your curriculum. Data encryption standard (DES) is a very well-known algorithm, and it is a symmetric key algorithm which was developed by IBM in early 1970s. So it was the major algorithm used in 70s, and DES is it uses 56 bytes key size, means the secret key which is used in this algorithm is of 56 bytes, and using this 56 bytes key, we have approximately this much of key combination, but it is considered to be insecure because this much combinations can be easily tracked down by brute force analysis. What is brute force analysis? So in cryptanalysis is also another branch of cryptography, but we will not look much into cryptanalysis. We will stick to our topic in encryption. And cryptanalysis, user message is tried to be hacked by introducers, and they will try every possible case in brute force analysis. Suppose if hacker uses brute force analysis, and he starts using one by one every key, starting from 1, 2, 3, and using every alphabet and every combination. So this much 70 something, this key combination can be easily cracked down in 3 to 4 days. So DES algorithm is nowadays not very used because key can be easily cracked by hacker. So concept of asymmetric encryption was introduced. Let's see in this diagram how asymmetric encryption works. In asymmetric encryption, there are two keys. One is public key and one is private key. So sender's plain text is converted into ciphertext using the public key of the sender. Remember, public key of the sender is used to convert the text into ciphertext, and public key is known to everyone, but sender's private key should be only with receiver. So receiver has already sender's private key, and while decrypting the message, receiver will use this private key of the sender and decrypt the ciphertext into original text. So here comes concept of two keys, public key and private key. But please note, especially in this case, the receiver's private key is not used in asymmetric encryption. So public key of the sender and private key is used in this asymmetric encryption, and hence it is very much secure than symmetric encryption, because in symmetric encryption there was a major concern about the sharing of private key. So asymmetric encryption was introduced, and now we will see one famous algorithm of the asymmetric encryption, and it is advanced encryption standard algorithm known as AES algorithm. So AES is a block cipher algorithm which was introduced by US government to ensure security and security of the classified data. And AES algorithm was first of all published in 2001 by Federal Information Processing Standard, it's FIPS, and it uses a bit more lengthy block size. So it has a 128-bit block, and the key combinations used in this algorithm are three types of keys are maybe used: 128 bits, 192 bits, and 256 bits. Means there are three versions of this AES algorithm, and three types of key can be used here. So we can see approximately this much of key combinations are generated using AES algorithm. So it is much more secure than the simple symmetric algorithm data encryption standard DES. Compared to DES, AES is much more secure, and it is widely used nowadays. So this was the AES algorithm, and let's see basic difference between symmetric and asymmetric encryption. So symmetric encryption, it uses only one secret key. For encryption as well as decryption, only single key is used for both the processes. While in asymmetric encryption, concept of two keys is introduced, means public key is used for encryption and private key is used for decryption, as we saw in earlier diagram. And the process of symmetric encryption is very simple, and hence it is also fast, but the process of asymmetric encryption is slow because it is very complex, but it provides much more security. So use of asymmetric encryption is advised. And symmetric encryption also requires sender and receiver Bo- both should know the secret key, means transfer of secret key should be done before the actual transmission of the message, and the security of this secret key is a very big question for symmetric encryption. That's why the concept of asymmetric encryption was uh, carried out. And in asymmetric encryption, public key can be shared to everyone, because despite knowing anyone's public key, we cannot deduce what is the actual message. So if we have ciphertext and public key, we cannot decrypt the message because we have not private key. So private or secret key is main component in this asymmetric encryption. And the what was the major concern in symmetric encryption, that was the security of the secret key, but it was this question was eliminated in asymmetric encryption, because we used the concept of two keys, public key and private. So we will see asymmetric encryption through a simple analysis. So okay, what is asymmetric encryption? As we see, two types of encryption are there: symmetric and asymmetric. In symmetric encryption, we will say, suppose sender is Alice and receiver as Bob. Alice want to send this message to Bob, and she will encrypt this message. Okay. Now she will send this message to Bob, but Bob cannot understand the message because it is ciphertext. So Bob needs to convert this ciphertext to plain text. Now, now sharing of the key is the concern. If key is shared through mail, then Hacker can understand the message. So asymmetric encryption was introduced to solve this question. As we see, this is the mailbox and it is open to everyone. Everyone can see mailbox publicly. So they will send their message. But no one has the private key of the mailbox. So only authenticated user will get the message. So both should have private key of and public key. Public key is known to everyone for senders and receiver. Okay, and this key are linked to each other through mathematical formula which is used in this algorithm, encryption algorithm. But hacker cannot derive this uh, private key or public key with each other. If if I have private key, then I cannot get public key. If I have someone's public key and I want to decrypt the message, I cannot decrypt the message without private key. So we will see how will they extend the key. So public key is exchanged between sender and receiver. All right. Now Alice will send this message and through ciphertext the message is sent to receiver. Now receiver will encrypt it through private key. Bob's private key is used to decrypt the ciphertext. So they have to only store private key. Okay. Now hacker will not be able to crack the message, and application of asymmetric encryption are in HTTPS websites. They are using asymmetric encryption. So in our website surfing, also in bitcoins, asymmetric encryption is used. So in symmetric encryption and asymmetric encryption, difference between both is known by you now. So let's see another example. Okay, so how hacker will try to get the message, and now we will see how attacks on the message are done, means which message is sent through transmission line. Hackers may follow the transmission line and make attack to obtain the information, and your useful data may be released, and content of the message may be said to anyone. So it is very risky, and outsiders can learn the content of transmission through and one more thing is there through analyzing the pattern of traffic, means the pattern of message sent by you. Hackers use tools to identify the pattern of the traffic, and by analyzing the pattern, they may know the nature of communication. Uh, so it is also very risky, means they can hence step by step deduce our message. So our message should be such that it should be difficult to detect, and passive attacks should be prevented. So these are passive attacks, and what are active attacks? So active attacks involves masquerade. Masquerade means I am not an authorized person, but uh, I will say that I am someone, and I will pretend to be someone, and try to get access of the message. Uh, or one more thing, hacker steals the ciphertext of message, and in between transition, he modifies the message. So modification of message may also be done, and one of the types of active attacks is denial of service (DOS). In denial of service, hacker steals the ciphertext message, and uh, the message is not further transmitted to the receiver also. So receiver will not be able to get the message anytime. Okay. This type of active attacks are there, but they are very easy to detect, and we can identify that active attacks are performed on our message, but we cannot easily prevent these active attacks. So it is very important to use strong encryption and decryption algorithm to avoid this type of attacks. So as we see, symmetric encryption, it uses an algorithm like DES, and converts the plain text using a secret key to ciphertext, and then ciphertext is transmitted, and receiver, when receives this ciphertext, he will decrypt this text using decryption algorithm already available with receiver, and he will use the secret key which is shared between sender and receiver, and finally receiver will obtain the plain text. So in output he will get the actual message what is to be conveyed. So there are basically five components: plain text, then comes encryption algorithm into picture, and using secret key, the plain text is converted into ciphertext, and at the receiver side, decryption algorithm needs to be performed. So what is the requirements for this much of security and this much of concern? So strong algorithm should be having these characteristics. If this algorithm is known to someone, despite knowing the algorithm, hacker should not be able to decrypt the actual message. Means if hacker has not key, then he should not be able to analyze what is the message. So algorithm need to be such a strong that without key, message cannot be known. And even if hackers get access to lots of ciphertext, and he also gets lots of plain text combinations, but he should not be able to crack down the key, or crack down the pattern of the cryptography. Means a hacker will try to perform brute force analysis or any encryption or decryption tool, but our algorithm should be strong enough that hacker should not be able to crack down the code. And in symmetric encryption, as we discussed, the transmission of this secret key should be performed securely between sender and receiver, because all the encryption and decryption method depends on the security of the secret key. If 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 the key is known to hacker, then all communication will be readable to hackers. Now, how will hackers will attack? So they may perform crypt analysis. Crypt analysis rely on the nature of the algorithm. And moreover, some hackers may also have some knowledge of general characteristics of the plain text. So they will perform brute force analysis to ensure they can crack the code and get plain text or even a key. If hackers can get access to key, then in future they will know every message which are sent. Means we will think that our messages are encrypted, but hackers will know each and every message if they have key. So we have to make sure that our algorithm is strong enough and key is safe uh, with us. So in brute force analysis, the hacker will try every possible key, but uh, our algorithm should be strong enough. So they will not get the context. And encryption algorithm is in first slide we see Julius Caesar's algorithm, that was block cipher algorithm, in which he shifted three steps up. Plain text was shifted three steps up. So T was coded as A and S. So block cipher processes plain text in fixed number of block size, and that much number of cipher block sized cipher text are sent in transmission. So DES algorithm that we see earlier, and triple DES algorithm and AES algorithm, that are some of the algorithms. Let's take a brief idea about data encryption standard algorithm, DES algorithm. It uses 64 bit of plain text blocks. It means our message is cut down in blocks of 64 bits. So each block is then encrypted using a key of length 56 bits. Then these blocks are transmitted, and at the receiver side, decryption algorithm is used, and text blocks are decrypted, and original text message or this plain text is received. So this DS algorithm was cracked down in 1998, and it was cracked down by Electronic Frontier Foundation. It introduced a special purpose machine to decrypt this algorithm, and they cracked down DS algorithm in less than 3 days. Means any key combination or any plain text, they can crack this in less than 3 days. So DS algorithm is not used nowadays because it is not useful. It cannot guarantee security of our data. So triple D algorithm was introduced later on in 1999 by DES standard 1999. How triple D algorithm works? Instead of using one key in DE algorithm, this algorithm, triple DE algorithm, uses three keys. So the security level is multiplied by 3 times, and uh, executions of this algorithm is also occurred in 3 rounds. So 3 into 3, or 9 times security is guaranteed in triple DE algorithm. And key used in triple D algorithm is having 168 bits. So as it is using 3 rounds of encryption, it is very slow, and block size used is 64 bits, which is very slow as well. So one more algorithm was introduced later on in 2001, that is advanced encryption standard. So this algorithm was introduced by National Institute of Standards and Technology, that is NIST, and in 2001 this algorithm was introduced, which used 128 bits length blocks, and keys used were of three variants, means 128 bits, 192 bits, and 256 bits. Using this number of lengths of keys. The algorithm encrypted the plain text to garbage text, and security is better than 3DS algorithm in AES algorithm, and efficiency is also improved. Efficiency is evaluated on the matters of security, computational efficiency, and memory requirements of the system, and hardware and software suitability, and flexibility of the algorithm. So this is the diagram of the AES encryption and decryption algorithm, in which you can see that 9 rounds are performed, and in the final round, the encrypted message is transmitted. So round 10 will be the transmission round, in which the ciphertext will be transmitted from sender to receiver, and reverse process will be done at the receiver side. It will use a decryption algorithm, and similarly with 10 rounds it will decrypt the ciphertext and get the original plain text. So it is more secured because it uses more round of more round of encryption in this AES encryption algorithm. So we can have more security about our data in this AES encryption algorithm. So one by one blocks are seen in this diagram. Blocks are one block is taken, then another, then third one, then fourth one, and similarly, these blocks will be encrypted, and while decryption, first come first serve in this manner. The first block will be decrypted first of all, then second, and similarly original entire length of text will be decrypted, and we will get the plain text. Now we will see another concern, which is the location of the devices. In packet switching network, which is used in the internet protocol, location of the devices is also make to be sure and secure. If hacker will know the location of devices, then it will be very easy to narrow down the search area for the hackers, and they will easily identify the message, and may be able to get our plain text also by using any crypt analysis like brute force analysis and etc. So end-to-end encryption needs to be incorporated. Means encryption is done at the system end. You have heard this term in WhatsApp also. WhatsApp uses end-to-end encryption in our private conversations with each other. So end-to-end encryption is very secure in transmission of our message. Data is encrypted, and encrypted data it crosses network. So data is not changed in between network. Encryption is ensured, and destination shares is private key with source, so that the destination may be able to decrypt the original message, and only host can encrypt the data, and only receiver will decrypt the data. And in this end-to-end encryption, traffic pattern is also not secure, so it is concern with this. And one more encryption technique is key distribution. There are four types of key distribution, in which in first type, sender A will select a key, and this key will be delivered to B. In another type, a third party C will select the key, and it will deliver key to A and D. So it is also a type of key distribution. And in third type, old key is used to encrypt, and new key is transmitted from sender to receiver. And in the last type, old key is transmitted, and third party transmits new key using old key to transmit from sender A to B. So key distribution is also used for this algorithm, and automatic key distribution tool is also available, in which key distribution center is there, which will distribute keys to every nodes. So first of all, host will send packets to every requesting connections. Then security service will buffer the packets and ask the distribution center for session keys. Then this key distribution center will provide the session key to every host, the sender and receiver, and buffered key transmission will be performed. So in automatic key distribution, session key is used for only one session, means only one logical connection, and it will be destroyed at the end of session. And this key will be used for user data. This user data will be encrypted using this session key. And one permanent key will also be there, which will be used for distribution of keys by key distribution centers, that is KDC. And the key distribution center, it will determine that which systems may communicate. Means if KBC will allow that which hosts will now share the data, and it will provide session keys to that sender and receiver. Means only one logical connection. In security service module, performance of end-to-end encryption will be carried out, and it will obtain keys for sender and receiver, which are those. And one more data encryption technique is traffic padding. In traffic padding, ciphertext is produced continuously. Means the flow of ciphertext is carried out one by one simultaneously. So hacker will get confused about which is the actual code. Means we have seen in a suppose at our Red Fort, if PM Narendra Modi's Kono is getting to flag ceremony, then similar type of vehicles, like 10 to 12 vehicles will arrive. So attackers or terrorists cannot easily identify that in which car prime minister is sitting. So similarly, traffic pending is using same concept, and it produces continuously blocks of ciphertext. And even if no plain text is there to perform encryption, then also traffic in traffic padding we will send randomly any information, and traffic padding will be carried out, and it will make sure that hackers cannot analyze the traffic pattern, and they will not easily be able to crack down the encryption algorithm. And one more encryption technique is message authentication. It provides protection against active attacks. So falsification of data is ensured. And message is known to be authentic if it is genuine and it comes from the legal source. Means authentic sender is known in this message authentication. And authentication allows receiver to verify that message is authenticate, it is not changed, uh, and when it is sent. So time of the message sending. And authentication is done using encryption as well. So it assumes that sender and receiver only has the keys. So the message will include error detection code, sequence number, and timestamp for ensuring these three characteristics. And in authentication without encryption, authentication tag is generated, and it is stick at the end of the every message, but messages are not encrypted. So this is also useful in broadcasting the message or in if single side is heavily loaded, then authentication without encryption is used. And one more technique of data encryption is message authentication code. It will generate authentication code based on shared key between sender and receiver. And this key is only known to the source, and receiver will ensure that the message is not changed in between transaction, and sequence is also maintained. So this is the diagram of message authentication using message authentication code. And one more encryption tool is one-way hash function. It accepts variable size message and produce fixed size tag, that is hash function. Okay. So example of hash function are secure hash function. It can be applied to any size of data block and produce fixed number of block size output, which we see earlier. So some of the hash function algorithm are secure as algorithm one, which uses input message less than 2 raised to 64 bits in processes in 512 bit blocks, and output is 160 bit digest. So it is this diagram of this SHA1 algorithm. And in public key encryption, it is based on mathematical algorithm, and it is asymmetric as we see earlier. This is the diagram of public key encryption, in which public key is known to everyone, but private key is known with only host only. So it will decrypt the message and ensure the message is authenticated. And one key is made public, and it is used for encryption, while a private key is used for decryption. It is made private. Okay. So these are the one by one steps of asymmetric encryption. Generating pair of keys using one key to encrypt and another to decrypt. And moreover, digital signature can also be achieved this in encryption algorithm. And at last, we will see some tools which you may explore for ensuring data encryption. One very well-known tool is TrueCrypt. So TrueCrypt is used for data encryption of our message, and it creates a virtual encrypted disk within your file system, and it is mounted in a real disk, and it encrypts entire partition on your hard disk, such as a store or a storage device, and it will perform that your data is secure. So you may explore this TrueCrypt tool. It is available on the internet. And one more open source encryption tool is Mailvelope. Mailvelope is a browser extension which enables exchange of encrypted emails. So emails are encrypted. So if a hacker uh, gets access through our email, he will not be able to understand the actual message, what is to be conveyed. So Mailvelope is also a very useful encryption tool. You should try these tools and note down these names: TrueCrypt and Mailvelope. So Mailvelope is also open source encryption tools. It is very commonly used. So okay, that's it for today, and thank you so much for your time. And I would like to thank Parul University and Professor Nita ma'am for providing this opportunity to get interaction with such bright students that you are studying during this time from home. So thank you, Parul University. Thank you, all of you. Okay, till next time. Goodbye. Have a nice future.
Okay.
Hello.
Hello. Okay. Thank you, sir, for presenting such a valuable slide and information about data encryption techniques. Hello, Jiten, sir. Hello.
Yes, we can close the session. Yes.
Okay. So we can leave.